I was working on an analogy to describe kind of the Web 2 dilemma, and hopefully this isn't too soon, but one analogy that kind of made this stick for me a little bit is that if Web 2 is someone sneezing on you during the pandemic, and Web 3 is a properly fitted N95 mask, then Web 2.5 is kind of like a chin diaper, right? And like I know there's a lot of different opinions and ideas on the efficacy of mask mandates, et cetera, but I think we can all agree that the chin diaper really didn't make a lot of sense. And that's kind of Web 2.5, right? It just doesn't make sense. It's sort of it's incongruous with the goals of blockchain and Web 3. Specifically, it undermines a lot of the value propositions that the Ethereum founders and a lot of the early builders in Web 3 sort of united around in the first place. So being able to build unstoppable applications with composability. When you start building on centralized infra run by single service providers, well then your app is no longer unstoppable. It stops as soon as that platform gets shut down. Once you stop building on open standards, the composability of your applications and of the stuff that you've built goes down quite a bit. And even if there was a standardization on these centralized servers, there's a limit to how much composability you can get when you're building on centralized building blocks, because the more centralized building blocks you compose, the more brittle your system becomes, because now you're basically, if one centralized building block in your giant compose system goes out, well now that ripples to breaking your entire system, as opposed to unstoppable smart contracts running on Ethereum, the way those work, where a new DeFi protocol can come along, integrate with an existing unstoppable DeFi protocol, and that composition can keep playing out until you get this this really rich tapestry of decentralized applications. Definitely hurts for usability if you're just doing one-offs all the time. And then I think on ownership, censorship, resistance, fairness, I'm going to try and paint this a little bit in a few examples. The first is how many people saw the article that Moxie Marlinspike from Signal wrote earlier this year? Okay, like let's say 30%. So he wrote, I recommend you look it up. He wrote a very, I think, well-intentioned, can we get levels down just a little bit? Very well-intentioned, well-thought-out critique of Web3 from someone actually trying to make a good faith attempt at building some decentralized applications in this space. And so one of the things that he did was build an NFT app, and to sort of kick the tires on like the guarantees that we think we have when we're building on NFTs, he basically built a single NFT, but depending on where you viewed it, whether you viewed it on OpenSea, Rarible, or in your own wallet, you got one of the three images shown on the screen. So like when you're actually buying the NFT or looking at it in a collection, you're seeing like this cool piece of artwork, and then by the time it makes it to your wallet, you get a poop emoji. And that's possible because the NFT was not hosted on decentralized data and using a decentralized data supply chain. It was using centralized servers to serve that that NFT. And for a lot of us who are sort of inspired by the ownership vision of Web3, that Web3 is enabling digital ownership, how can we own things when the actual information artifacts that we're owning are controlled by centralized intermediaries? I think this experiment also highlighted another interesting place where we're falling short today. Sorry, we got some clicker. There we go. So this experiment also highlighted a way in which we have censorship in quote-unquote Web3 today, because once OpenSea realized that Moxie had done this, they actually delisted his NFT from OpenSea, which if OpenSea was doing that as a individual application and doing that for sort of their own purposes, and I think that's fine, like we believe in choice at the level of projects and individuals. But the problem was that so many other projects in the ecosystem were building on the OpenSea API that him getting delisted from the OpenSea application also made it so that the NFT stopped showing up in wallets and all these other places where you would expect to see an NFT that you had purchased, right? So this is a real example of censorship that's happened just this year in the context of the blockchain data supply chain for a use case that we all, I think, care a lot about. Another one, this is a little bit more speculative, but I think it's an interesting one just as a thought experiment, is index or extractable value. This was an idea that was put forth by someone in our community. You can think of this as being a little bit analogous to like MEV, or also payment for order flow, which got a lot of attention this past year or two when people realized that Robinhood's business model for offering free stock trading to retail investors was that they sell the order flow to giant hedge funds like Citadel, and then Citadel, with its privileged access to these to this order flow, can then like extract all this value at the expense of the retail investor. You could imagine a world where if we were all accessing the blockchain, where we expect more of our financial lives to exist over time, and we were all accessing it through a centralized intermediary, that centralized intermediary might gain a lot of alpha from being the one that's seeing the sort of Google Trends style data around accessing and querying our financial lives as it exists on the blockchain. Okay, so that's kind of where the Web3 vision is at today, and sort of the importance of keeping the blockchain supply chain decentralized. Let's talk about where Ethereum is going and the ways in which a decentralized blockchain data supply chain supports that future vision. So for those that saw Vitalik's EthCC talk earlier this year, you might have come across these new, let's call them work streams that are all happening in parallel. So they're not sequential milestones, but they're all parallelized work streams that are happening in the Ethereum ecosystem: the merge, the surge, the verge, and the splurge. And the diagram on the left can look a little intimidating. We're just going to focus on a few aspects of this roadmap, specifically parts of the verge, the purge, and parts of sort of the light client vision of Ethereum. So a brief overview. The Verge, one of its sub-goals is around supporting stateless clients. Stateless clients allow validators to sort of be small and light while having like heavier specialized builders in the right side of the blockchain data supply chain. There's different approaches to this: weak statelessness, strong statelessness. Weak statelessness is where builders sort of provide the witness of state that's being used by a transaction. In strong statelessness, the end user, actually, when they submit a transaction, they would also have to submit the state that transaction is going to access as a witness to the network. The purge is about history expiry as well as state expiry. So EIP44s covers the history expiry side of things, which is the idea that after a certain amount of time, in contrast to the way that Ethereum works today, full nodes and validators would be allowed to drop, they'd be allowed to prune historical blocks, basically keeping the storage footprint of these nodes lighter. And then state expiry basically attacks the unbounded state growth of Ethereum, where certain state, if it's not touched frequently enough, again would be allowed to expire. And then light clients, we're going to touch on a little bit in the next screen, but I think they're interesting to bring up here because they share a lot of the same requirements as sort of those previous two milestones, and they're also part of the solution space, right? Because a lot of this stuff boils down to being able to access state and data. But the problem with light clients is that today, at least, light clients rely on altruism from the full nodes in the Ethereum network. So if those full nodes decide to support the light client protocol and serve data to these light clients, then it works out great. But the reality is that because of that lack of incentives, as Piper, one of the researchers working on this, noted, basically the light client protocol in Ethereum is a vast desert of starved clients desperate for data. Historical blocks or pruned blocks from the the blockchain, or expired or uncached state. So in the case of state expiry, it's expired state. In the case of stateless clients, it might be just state that the builder or the user needs that's not cached locally. And the solution space breakdown here, I think can be broken into two larger categories. One is financially incentivized approaches. So we mentioned those light clients needing cooperation from the full nodes, which right now don't have an incentive. So things like the Graph, things like Pocket Network could fit into that category. The other category here is using more like tit-for-tat incentives, which are not financial incentives, but this is kind of how like the BitTorrent network works, for example, where if you're being a good citizen in that network, uploading data as much as you're downloading, then there's sort of this reciprocity that you get, and that's the approach being explored by projects like Portal Network, using things like gossip protocols and DHTs, which again are techniques from BitTorrent and now IPFS as well. And so why are we doing all this? Like, why are we getting rid of all this state? Why are we getting, are we doing it just for the fun of it? No, we're getting rid of this state and this history for a purpose, and that purpose is scaling Ethereum in a decentralized way. So simply put, what that means is being able to fit more transactions into a block, being able to have bigger blocks while maintaining a small footprint for validating clients and light clients. And as an example of this, one of the EIPs that's out there right now is called EIP 4488. It proposes a approximately 5x cheaper, 5x reduction in gas costs for call data. This is about supporting like the Ethereum like rollup, centric future. But the reason that they feel comfortable doing this, which was inevitably going to lead to bigger blocks or more full blocks, is because it's intended to be paired with EIP 44s, which is one of the proposals in the Purge, which is, specifies dropping this requirement for full nodes and validator nodes to keep around all this historical blocks past a certain point. So that's what all this really boils down to, is decentralized scalability of Ethereum. Okay, so this last one's kind of a bonus section. I think this is really interesting from both a couple standpoints. One is that the fire hose, which we briefly noted earlier, is a next generation extraction technology. I think it's interesting, A, because I think it should impact the way that Ethereum clients get built in the future. But I also think it's interesting because it's an example of sort of this positive externality coming from an ecosystem that's tackling the blockchain data supply chain in a decentralized open source way, right? So this is Firehose is a technology originally created by Streaming Fast, which is another core developer in the Graph ecosystem. Before I get into how it works, it's worth calling out some of the problems with JSON RPC and the way that it works today. So, most of you I think are, show of hands, people that are familiar with JSON RPC. Okay, most people in the room. So this is how you access, data from like a Geth or an Aragon client today. It basically depends on a running program to read data. So if you look at this diagram on the left, you kind of have this fan-in architecture where all the users are sort of hitting a running process. That process consumes CPU. That process becomes the bottleneck for getting data out of the node. And then because you need to have heavier nodes to serve all the data that people want, like archive nodes, potentially running parity trace, it's also incredibly intensive on memory and solid state disks, because in order to actually efficiently access that data, you need to provision a lot of both of the latter. It's difficult to get query intermediate state, so JSON RPC really only lets you query data as of a block. You can get a little bit more by using the parity trace API, but it's still incomplete, also very cumbersome. It can be difficult to debug, so if you're using a subscription to like ETH get logs, for example, via Infura, like we've encountered this, in our own stack, that like sometimes, in the past, messages will just get dropped, due to, transient network events or partitions, and there's just no way to debug that. Like you just miss the message, and like it's very, very difficult to figure out that like, hey, a message you should have gotten never made it to you. And there's a pretty incomplete verifiability story. Some of the data you want to get out, you can get a Merkle proof for. But other data, like if you're using like the ETH get logs interface, for example, there's not a really easy way to get a compact proof that says you didn't miss any logs, within some range of blocks. So what's the solution? We think the solution is the Firehose approach. It's streaming first. So if you look at the diagram on the left, data is being as soon as it's available, it is being broadcast out in a fan-out approach rather than this fan-in. It's being distributed as flat protobuf files. So these can be distributed across, commodity hardware, and using things like, Google Cloud Object Storage or Amazon S3. Because, now we have these distributed flat files, now we can parallelized workloads on those files, all without even touching the blockchain node. So this is much more akin to like what you would see in like a Hadoop, big data architecture, where you have all these flat files distributed across commodity hardware, and then you have these compute clusters that can be scaled independently and spin up concurrent and parallelized access for doing the sort of transform steps on that data. And so when you do that stuff, you get, compared to the approach of using JSON RPC today, you get a 1 to 2 order of magnitude increase in read performance based on the use case. There's a couple integration strategies that I'm going to move through here real quick. The first is just integrating this as a drop-in replacement for JSON RPC. Basically have it be something that runs locally on the node. When you're running your node, instead of accessing via JSON RPC, you would be using sort of like the Firehose stack. And that's kind of like a really basic integration. But in the future, you also might want to actually improve the verifiability guarantees that you get from Firehose. So you could imagine sort of the Firehose instrumentation logic running as a WASM process that is implemented as a read-oriented rollup, so like an optimistic rollup or even a ZK rollup that actually gives you some guarantees on the validity of the sort of data that is extracted through that Firehose instrumentation process. And then the final approach that, and again, these are still very early in us thinking about this, but the final approach is you could even potentially integrate Firehose files into the consensus process itself. Now, you probably wouldn't want to do that initially, because initially there's a strong benefit to having what's called like data agility, being able to evolve the schema, evolve the instrumentation logic based on sort of a changing understanding of what's needed. But as those integrations stabilize, there might come a time and point where blockchain core developers decide to say, hey, we'll reference maybe the Firehose files from the previous epoch at some future block, right? So that they're actually, you have some guarantees natively in consensus. I'm happy to announce that actually we have our first example recently of a blockchain core development team self-serving their Firehose integration. And I think this is going to be really important for every blockchain core development team, especially and including the Ethereum ecosystem, to eventually own their Firehose deployment so that they can sort of maintain that for their own use cases. And then that also has secondary benefits like basically automatic integration with protocols like the graph. There's another integration story here related to EIP44 called shim clients, but we're out of time, so if you're interested in that, feel free to come up to me and find me afterwards. Highly recommend checking out Alex B. from Streaming Fast's talk this week on substreams, and then also Vincent from Masari has a talk on standardized subgraphs, but they're heavily using Firehose and substreams as part of their dogfooding. So yeah, thank you guys very much. That's my talk. Do we have time for questions, or I guess we have time for a couple questions. We have a mic in the back.
Is there a published specification for the Firehose?
There's pretty detailed documentation. I wouldn't say it's at the level of like an IEEE spec or anything like that, but there's very detailed documentation on the architecture, how it works. The repos are open source. So if you just search like Firehose, the graph, docs, you'll find it real quickly. Dave in the front.
So thank you. For the stateless clients in like EIP 4444, is there any way to estimate or predict like how, like basically what I'm trying to understand, like can the graph network itself as a whole essentially like earn income from providing a service of like, basically the current Ethereum nodes retiring the state, but then graph nodes serving up that, and then as a whole, like the network getting some profitability from that?
Yeah, it's a really good question. So this is, these are sort of emerging ideas in our ecosystem, but like increasingly my view of the graph is that it is going to be like a multi-service ecosystem. So like today, the primary service is, you do ETL into a subgraph and query it via GraphQL, but there might be a range of services, for example, accessing Firehose data directly or JSON RPC data directly, or data in a key value store or a SQL store. And I think all of those could potentially be supported side by side in different like namespaces, if you will, within the graph ecosystem. And in that context, then you could imagine, yes, graph indexers and service providers being the the endpoint that like light clients use to get their data. It could also be what blockchain nodes themselves use to hydrate data and some of these other related to these other milestones. So yeah, I think it will be a source of query volume in the future on the graph. Yeah, great question. Cool. I think that's it. Thank you guys so much for your time and attention.